So section 10-4, this is on page 642. 642. This is a rational equation, a radical equation, a radical equation. I run into this in my physics class. If you had to solve for y, it's really not all that hard. If you put in the value of x, say x is equal to 2, then put 3 times 2, take the square root on your calculator, you can get the value of y. But what if you had to solve for x? So if I had to solve for x, I need to isolate the variable I'm looking for. This is already isolated for y, but what if I want to solve for x? Well, the way that I can do this is under the radical. I can square the whole thing. I can square both sides of the equation. So what I mean by this is so y equals the square root of 3x, but I can square everything. Why would I do that? Because this becomes y squared equals 3 squared, this is the radical 3 squared, which is 3, right? Radical 3 times radical 3 times itself is 3, times the square root of x squared. And x squared of x times the square root of x is x. So I end up with y squared equals 3. That 3 comes from, I squared it, squared radical 3. Radical 3 times 3 is 9. Square root of that is 3. And this is x. Divide both sides by 3. So I get y squared all over 3 is equal to x, or better yet, x equals y squared all over 3. So when you want to solve for something, a variable that's under the radical, first off, you have to get the radical all by itself. What I mean by that is if I had given you y equals the square root of 3x minus 1, before you can square both sides, you have to get the radical all by itself on one side of the equal sign. And the way I would do that would be to add the 1 first. So this would become y plus 1 equals square root of 3. Now I can square everything. So I would square this whole expression. This whole thing gets squared, and this whole thing gets squared. So this is y plus 1 times y plus 1 equals, well, that squared is 3x. And remember your rules here. This is use FOIL, or you get a special product. So that's going to be y squared plus 2y plus 1. Yeah, using my FOIL equals 3x. And then I can solve for x. Okay. Let's look at the examples in the textbook. So I like the one on the top of page 643, good physics experiment. The one that's the one on the very beginning. Oh no, the one that, no, I don't want to do that one. Yeah, we'll do the one on the top right-hand side. Sorry, that's the speed, the fastest speed a car can go around a turn. Good physics experiment or situation. V, which is the speed of the car, equals the square root of 2.5 times the radius of the turn. How tight is the turn? The tighter the turn, the smaller the radius. The wider the turn, the longer the radius. And so this is easy if you want to figure out, if the radius, we call that the radius of curvature. If the radius of the turn is like 9, Well, put 9 in there, and you just multiply that out and take the square root on your calculator. You can figure out how fast the maximum speed that you can go around the turn. But what if I gave you the speed and I wanted you to solve for r? So that's what they're doing in this question on this example at the top of page 643. They say, what if the road is designed for a maximum speed of 65 miles per hour? So what if v is 65? How do I solve for r? Well, square everything. So v squared, I'm going to square this. I'm going to square this. So this becomes v squared equals 2.5r. I can put in, the example is, what's the value of r when v is equal to 65 miles per hour? That's the example in the book. So I can put in 65 squared equals 2.5r. (65 squared), which is 4,225, equals 2.5r. Divide both sides by 2.5. And that comes out to be 1,690. This is in feet, the way that they've done it. Or I can write it, r equals 1,690 feet. That's the radius of the turn. The other one, this is a little different. If you had something like this is just a little weird. Square root of x plus 1 equals x minus 1. Okay, well, to solve for that, we want to solve for x. We square both sides. So this whole thing's squared because it's all under the radical. The whole thing's under the radical. So that squared is x plus 1. That's easy. But this one, be careful because it's, remember, this is x minus 1 times itself. So that's x minus 1, x minus 1. So we have to be careful. That's x squared minus 2x. Negative 1 times negative 1 is plus 1. Again, that's x times x is x squared. I'm doing FOIL. It's minus x is minus 2x. Minus 1 times minus 1 is plus 1. So x plus 1. Now let's set this equal to 0. So I'm going to subtract this to the other side. I subtracted that to the other side. Oh, that's a plus. X plus 1. It's okay. So this is going to be x squared minus 2x minus x is minus 3x. 1 minus 1, because that is 0. So that's the answer to that. But now we need to find out what the value of x is. Now I can factor out an x, because this is x times x, and that's, so I can factor out an x to the side. So x times x is x squared minus 3, because x times is that. X times x times x is x squared. Okay, so this is set equal to 0. So what are the solutions to this? Well, the solution is going to be x equals 0, or x minus 3 equals 0, which means that x equals 3. On Math Excel, you would type that as x equals 0, 3. But hold the phone, Wilbert. You should check this. How am I doing on time? Okay, I'm okay. I am going to check this. I'm going to put in 0 for x into the original equation. So I'm just checking. 0 plus 1 equals, the original equation was this. Equals 0 minus 1. So 0 plus 1 is 1. The square root of 1 is 1. Negative 1. That's not true. I didn't make a mistake. It's not true. It's called an extraneous solution. If I didn't check it, I wouldn't know that 0 is not an actual solution for this. It came out here, but didn't work when I put it back in. This is just one of those odd situations. How about 3? Well, if I put in 3, let's check with 3. So 3 plus 1 and 3 minus 1. Well, 3 plus 1 is 4. 3 minus 1 is 2. Does the square root of 4 equal, which is 2, equal to 2? Yes, that checks. So your extraneous solution is 0. Turns out it's not valid. The correct solution is x equal to 3. All right, extraneous solution, that's the valid solution. Okay, so you have homework on this on Math Excel. God bless you all. I hope you're doing okay. I miss you all, I really do. If you look out here, there's nobody there. Einstein's over there, the wall. Oh, there's my desk. All right, I'm not playing any of my music on Spotify. It's so sad. Anyhow, take care all.